It is indeed possible to bore under a poured slab, such as a driveway, and this technique is commonly employed for installing utilities like electrical or water lines without disrupting the slab's integrity. Here is an overview of the process. Firstly, locate the underground utilities. Before commencing any digging, identifying any buried utilities is crucial. Contacting the local utility companies or hiring a utility locator service can achieve this. Secondly, determine the bore's depth and location. Precisely mark the intended bore location and ascertain the necessary hole depth. Employ a level to guarantee the bore's levelness and alignment with the utility line's trajectory. Thirdly, select the appropriate boring equipment. Given the diverse range of boring equipment available, selecting the right tool for the job is important. A handheld drill equipped with an auger bit might suffice for smaller bores, such as those intended for electrical lines. Conversely, larger bores, like those for water lines, may necessitate a hydraulic boring machine. Fourthly, drill the bore. Carefully drill the bore, adhering to the marked location and depth. Exercise caution when drilling near existing utilities to prevent damage. Fifthly, install the utility line. Upon completing the bore, carefully thread the utility line through the created opening. Sixthly, fill the bore. Backfill the bore with a suitable material like sand or gravel. This step reinforces the bore and prevents potential collapse. Here are some helpful tips for boring under a poured slab. 1. Use a sharp drill bit and lubricate it with water or cutting oil. This will minimize friction and reduce the risk of overheating. 2. Drill slowly and steadily to avoid creating excessive vibration that could crack the slab. 3. If you encounter any unexpected obstacles, such as rebar or large rocks, stop drilling and consult with an experienced professional. 4. Always wear appropriate safety gear, including gloves, eye protection, and a dust mask. When dealing with underground utilities, it's important to understand some of the dangers involved, as well as best practices for safety. Firstly, electrical hazards. Underground electrical cables pose a significant risk of shock and electrocution if struck during digging. Always call before you dig to locate these lines. Secondly, gas leaks. Puncturing a gas line can result in dangerous leaks, explosions, and potential health hazards. Again, knowing the location of these lines is critical. Thirdly, water damage. Damaging a water line can lead to flooding, property damage, and water service disruption. Fourthly, communication disruptions. Damaging fiber optic or communication cables can interrupt phone, internet, and other communication services. Fifthly, structural damage. Unintentional damage to buried utilities can compromise the structural integrity of surrounding infrastructure. Here are some important safety measures to keep in mind. 1. Call before you dig. Always contact your local 811 service to have underground utilities marked before starting any excavation. 2. Utility maps. Obtain and review utility maps to understand the location of buried lines in your work area. 3. Visual inspection. Carefully visually inspect the area for any signs of underground utilities such as markers, pedestals, or valve boxes. 4. Hand excavation. Use hand tools when working near marked utilities to avoid damaging them with machinery. 5. Potholing. Employ potholing techniques using vacuum excavation or hand digging to expose buried utilities safely and verify their location. 6. Proper equipment. Use appropriate boring or trenching equipment designed to minimize the risk of utility damage. 7. Safety training. Ensure that all workers involved in the excavation are properly trained in utility location and damage prevention. 8. Emergency plan. Develop an emergency plan in case of a utility strike, including evacuation procedures and contact information for emergency services and utility companies. 9. Personal protective equipment. Wear appropriate personal protective equipment, including safety glasses, gloves, and protective clothing. 10. Continuous monitoring. Continuously monitor the excavation area for any signs of utility damage, such as unusual odors or hissing sounds. Ignoring these safety practices can lead to serious consequences, including injuries, property damage, fines, and legal liabilities. Always prioritize safety and follow established procedures to protect yourself, your coworkers, and the public. When choosing boring equipment for your project, consider the following factors. 1. Bore diameter and length. Match the equipment's capabilities to the required bore diameter and length. 2. Soil conditions. Select equipment suitable for the type of soil you'll be boring through, such as clay, sand, or rock. 3. Utility type. Consider the type of utility being installed, such as electrical, water, or gas, and choose equipment that minimizes the risk of damage. 4. Access and space. Evaluate the available workspace and access points to ensure the equipment can be maneuvered and operated effectively. 5. Power source. Determine the required power source, such as electric, hydraulic, or pneumatic, and ensure compatibility with the job site. 6. Safety features. Look for equipment with safety features like automatic shut-off, overload protection, and emergency stop mechanisms. 7. Ease of use. Choose equipment that is easy to operate and maintain, reducing the risk of errors and downtime. 8. Cost. Balance the cost of the equipment with its performance, reliability, and long-term value. There are several types of boring methods that can be used, each with its own advantages and disadvantages. 1. Horizontal auger boring. This method uses a rotating auger to excavate soil and simultaneously install casing. It is suitable for a variety of soil conditions and can be used for lump bores. 2. Directional drilling. This method uses a steerable drill head to create a curved bore path. It is ideal for installing utilities under obstacles like roads, rivers, and buildings. 3. Pipe ramming. This method uses a pneumatic hammer to drive casing through the soil. It is suitable for short bores in unstable soil conditions. 4. Microtunneling. This method uses a remotely controlled tunnel boring machine to excavate soil and install pipe. It is used for large diameter bores in urban areas. 5. Jack and bore. This method uses hydraulic jacks to push casing through the soil while simultaneously removing soil with an auger or other excavation tool. It is suitable for a range of soil conditions and bore lengths. When it comes to backfilling the bore, consider these points. 1. Material selection. Choose a backfill material that is compatible with the surrounding soil and provides adequate support for the utility line. Sand, gravel, and flowable fill are commonly used. 2. Compaction. Compact the backfill material in layers to prevent settling and ensure proper support. Use a hand tamper or mechanical compactor, depending on the size of the bore. 3. Avoid large rocks. Remove any large rocks or debris from the backfill material to prevent damage to the utility line. 4. Proper cover. Ensure that the utility line is buried at the proper depth according to local codes and regulations. 5. Marking. Mark the location of the utility line with warning tape or other markers to prevent accidental damage during future excavation. If you encounter a rebar while boring, here are some steps to take. 1. Stop drilling. Immediately stop drilling to avoid damaging the drill bit or the rebar. 2. Assess the situation. Determine the location and orientation of the rebar and assess the feasibility of continuing the bore. 3. Consult with a structural engineer. If the rebar is part of a critical structural element, consult with a structural engineer to determine the best course of action. 4. Alternative route. If possible, adjust the bore path to avoid the rebar. 5. Cut the rebar. If it is necessary to cut the rebar, use a rebar cutter or grinder and follow proper safety precautions. 6. Reinforce the slab. After cutting the rebar, reinforce the slab with additional rebar or other materials to maintain its structural integrity. 7. Document the changes. Document any changes made to the rebar or the slab for future reference. By carefully following these steps, you can safely and effectively bore under a poured slab while minimizing the risk of damage to utilities or the structure itself.